So this one now is asking you to identify whether a set of points is coplanar or non-coplanar. Okay? So it is going to be one or the other. Right? So this should never be an answer, so don't even worry about that. So when you look at this, we're looking coplanar versus non-coplanar. So the first thing I can do is I can find any set of 2 or 3 points is always considered what? 2 points, 3 points. It doesn't matter where they fall. Okay, those are always coplanar points. So L and J, you can see they both fall in the unshaded plane. Q, J, and O. So Q and J fall in the unshaded, and O in the shaded. But because it's a set of 3 points, you could actually connect them into a triangular figure and then extend the sides infinitely to form a plane. Right? And so any set of 2 or 3 points is always considered coplanar. It's not until you get to 4 or more that you have to distinguish. So here, what I would do when you're testing these is find any 3 points from the set that determine a plane. So here, if I look at N, O, and K, so N, O, and K, those are all points on the shaded plane. So then I just check the last point, Q. Is Q also on the shaded plane? No. So this would be a set of non-coplanar. And just follow that example for each. So I'm going to use N, Q, and J. So here's N, Q. Well, so here, those 3 aren't on the same one, so I'm going to go to point P. So Q, J, and P are all on the unshaded plane. Is N on the unshaded? No. So that would be a set of non-coplanar points. Here, if I look at Q, J, and K, Q, J, and K are all on the unshaded plane, so I test M. Is M on the unshaded plane? Once again, no. And then finally, N, O, and M, those are all on the shaded plane. Check J. J's not, so once again, non-coplanar. Okay, so the easiest way to test these is just to find 3 points that determine a plane, and then test the last point. Is it on the same plane or not? And that will give you the solution that you're looking for.